everyone, in grade 9 we will start with a new lesson, which is similar triangles. In this lesson we have two objectives. Objective 1, the definition of similar triangles. Objective 2, prove that two triangles are similar and find the ratio of similarity. We will start with the introduction. As you see here in figure, I have triangle ABC where the three sides are of given length. BC 4 cm, AB 2 cm, and AC is 3 cm. The three angles of the triangle ABC are marked as shown in figure. So what did I do here? As you remark here in figure, I have constructed the triangle A', B', C', where BA', C' is equal to the angle BAC. A', C', B' is equal to the angle ACB, and the last angle ABC is equal to the angle A', B', C'. In other words, I can say that the angles of these two triangles are respectively equal. This is not the only condition that I have constructed the triangle A', B', C' by it. I have another condition, if you remark, which is I have multiplied all the sides of the triangle ABC by 2. That is, A', B' is equal to 2 times AB, which is 2 times 2 equal 4. A', C' is equal to 2AC, which is 2 times 3 cm, that is 6 cm. At last, B', C', I will get its length by multiplying BC by 2, which is 4 times 2 is equal to 8 cm. I can write these three equations here in another way. I want to write it in a ratio form. That is, I can say A', B' over AB is equal to 2. Also, I can say that A', C' over AC is equal to 2. Similarly, B', C' over BC is also equal to 2. So here we get A', B' over AB is equal to A', C' over AC, and B', C' over BC, which is equal to 2. That is, I will call it K. This K represents for us the ratio of similarity. As you remark here, these two triangles are similar triangles, where all the angles of the first triangle are equal to the angles of the second triangles respectively. And the ratio of the sides is proportional. You see here, this K is equal to 2. This 2 is greater than 1, as you know. So as you see here, the size of the triangle A', B', C' is greater than the size of ABC, and that's something we will speak about it later. Now, in this figure, the same triangle ABC with the same length of the sides, BC 4 cm, AB 2 cm, and AC 3 cm. I want now to multiply the sides by 0.8. I will get a triangle A', B', C', where B', C' 3.2, A', B' 1.6 cm, and at last A', C' is 2.4. So now we can write these three equations. A', B' is equal to 0.8 AB, A', C' is equal to 0.8 AC, and at last B', C' is equal to 0.8 BC. We can write these three equations in the ratio form. A', B' over AB is equal to 0.8. A', C' over AC is also also equal 0.8, and similarly the last ratio, B prime C prime over BC, will be also equal to 0.8. So we can write that the three ratios are equal to 0.8. I will reassure for you that you have to keep in mind that the angles of the two triangles must be respectively equal. That is, BAC equal to B prime A prime C prime, ABC equals to A prime B prime C prime, and the last one, ACB, is equal to A prime C prime B prime. So as you notice here, this K, which is 0.8, is between 0 and 1. Now, can you tell me, did the size of the triangle A prime B prime C prime get bigger or smaller? Yes, of course, as you said, it got smaller. So here we say that A prime B prime C prime is the reduction of the triangle ABC. To sum up, as you saw in the first activity, I multiplied the sides of the triangle ABC by 2. Then K is greater than 1. So I say that the triangle A prime B prime C prime is an enlargement of the triangle ABC. And if K is between 0 and 1, then I say that the triangle A prime B prime C prime is a reduction of the triangle ABC. As you saw in the second activity, when I multiplied the sides by 0.8, they became smaller. Then I say that A prime B prime C prime is a reduction of the triangle ABC. So here comes the definition of similar triangle. What's the meaning of two similar triangles? We say that two triangles are similar if the three angles are respectively equal and the corresponding sides are proportional. So ABC and DEF are similar triangles when BAC is equal to EDF and ABC is equal to the angle DEF and ACB is equal to the angle DFE. And as we illustrated in the activities, we will have the ratio of similarity, which is AB over DE is equal to AC over DF is equal to BC over EF will be equal to K. Now we will start with the ways to prove two triangles similar. In order to prove two triangles similar, I have three cases. The first case, if two angles of one triangle are respectively equal to two angles in the other triangle, then they are equal. So as you see here in this figure, I have the angle ABC is equal to the angle DEF and the angle ACB is equal to the angle DFE. Then simply by proving that two angles in the triangle ABC is equal to two angles in the triangle DEF, then these two triangles are similar triangles. Simply we can deduce that the angle BAC is equal to the angle EDF. Now we want to write the ratio of similarity. In order to write the ratio of similarity in a correct way, we have to write first the name of the triangles in a correct method. I have the triangle ABC. How can I write the name of the triangle DEF below it? I'll start with the angle of vertex A. You see that the angle of vertex A is equal to the angle of vertex D. So below the letter A, we write D. Now the angle of vertex B. As it is marked in the figure, ABC is equal to the angle DEF. So below B, we write E. And at last, the angle of vertex C is equal to the angle of vertex F. Now, I have triangle ABC is similar to the triangle DEF, writing the names in a correct way. How can I find the ratio of similarity? First, you take the two letters of the triangle ABC, that is AB, and the two letters of the triangle DEF, that is DE. That is AB over DF is equal, now we take the first and the third letter, AC over DF. And the last ratio, BC over EF. So it is AB over DE is equal to AC over DF is equal to BC over EF. Now, we want to solve an application on the previous case, which is exercise number 6, page 93 in your books. As you see in figure, I have triangle PST, a right triangle at S, and PLA is a right triangle at L. The first part, it is required to show that the two triangles PST and PLA are similar and to write down the ratio of similarity. In the two triangles PST and PLA we have to find two angles in triangle PLA which are equal to two angles in the triangle PST. Can you find one? Yes. At first, it is the angle SPT, which is equal to the angle LPA, which is a common angle. Obviously, as you see, the angle LPA is an angle in triangle LPA, and the angle TPS, which is the same angle as LPA, is an angle in triangle SPT. Can you tell me what's the second angle? The second angle is PST equal to PLA, which is equal to 90, which is given. So now we proved that these two triangles have two angles respectively equal. So simply I can say the two triangles are similar by the case angle. Now I want to write the ratio of similarity. As we said previously, in order to write the ratio of similarity, we have to write the names correctly of the triangles so that it would be easy to find the ratio of similarity of the two triangles. PST. Now, what is the angle that is equal to the angle of vertex P in PST and the triangle PLA? It is the angle of vertex P. And the angle of vertex S, it is equal to the angle of vertex L. And at last, the angle of vertex T is equal to the angle of vertex A. So PST and PLA. Now, PS over PL, we take the first two letters. We take now exactly the first and the third letter. PT over PA. And the third ratio is ST over LA. So this is the ratio of similarity. Now, in the second part, I have AP equal 5 cm, LP is equal to 4 cm, PS is equal to 8 cm. I want to calculate LA, TP, and TS. I will start with LA. Do you know how can I find the measure of the side LA? Yes, as you noticed, the triangle PLA is a right triangle at L, so we apply Pythagoras theorem. By applying Pythagoras theorem, I have LA power 2 plus LP power 2 equal PA power 2. So LA power 2 plus 4 squared equal 5 squared. I continue the calculation. It is 25 minus 16, it is 9. So LA is equal to radical 9, it is 3 centimeter. So I write on the figure now that LA is 3. I want to find the measure of TP and the measure of TS. Can you tell me what's the method that we will use in order to find the measure of TP and TS? Yes. will start with